Our project will detail all entropy involved in a student taking a chemistry test, from the physical mechanical energy involved in the writing to the production of each individual instrument used in the process, including the pencil, paper, ink on the test, and the calculator. Some assumptions were made while doing the calculations in order to standardize the information, and this presentation will detail those assumptions. As taking tests is something us BCA students experience all too often, we felt that this project would give us a chance to look at it in an interesting way. When the recording goes beep, press the right arrow key to go to the next slide. Beep. A very important part of the chemistry test is making sure you have a good pencil to use and an eraser that works. The retroanalysis of the pencil can be split up into the graphite, wooden body, paint, and eraser that it includes, each with a very interesting path it follows. Beep. These are the thermodynamic values associated with writing. In regard to the actual mechanical energy involved in taking the test, assuming the test taker uses all 51 minutes of the BCA class period and writes at the same intensity throughout. Beep. Most important about the pencil is the pencil lead, which is released onto the paper. Pencil lead is made mostly of graphite, not actual lead like many people assume. Graphite is made of layers of carbon atoms which slide off easily when pressured, which is why pencils can write so smoothly on paper. The graphite in pencil lead is not actually pure graphite. It is a specific ratio of graphite powder, clay, and water mixed together and baked at a high temperature. Beep. The end of graphite's journey is when the BCA Mart receives the finished pencils from the pencil factory. Using delta G of formation values, we can calculate the delta G of formation for the combustion of octane. Assuming that the transport truck has a mileage of 20 miles per gallon and that the BCA Mart, where the pencils will be sold, is 100 miles from the pencil manufacturing factory, the process has these thermodynamic values, assuming the temperature of the gas chamber is 353 Kelvin. Beep. The step before this occurs at the pencil factory, when strands of pencil lead are inserted into the hollow finished wooden bodies of the pencils. Assuming it takes 5 minutes to do this, we have the following thermodynamic values, also assuming it is done at STP. Beep. Before this, the pencil lead mixture of clay, water, and graphite is extruded into long strands and baked at 1255 Kelvin. This is done to harden the mixture and create the desired hardness of the lead. Leads come in different hardnesses on both numerical and lettered scales. However, most often students will be using a number 2 pencil on the test. Assuming there are 100 kilograms of the mixture, there will be the following thermodynamic values. Beep. Previous to this, the clay, water, and graphite powder are mixed together in the correct ratio for the desired consistency, resulting in the following thermodynamic values. Beep. Before this, the graphite and clay are transported on a large cargo ship from China to America. Many products in the United States are made in China, so it is a fair assumption to make that these pencils originated there. Assuming about 1.5 million gallons of fuel, about a 12,000 mile distance, and an internal temperature of 353 Kelvin, there are the following thermodynamic values. Beep. The origin of this process is at the graphite mines where, assuming an 8-hour workday and a 220-pound miner, the following thermodynamic values represent the amount of Gibbs free energy and entropy involved in the process. To find these values, we assume that a person of the same size sawing wood had the same enthalpic value as someone mining, so these values are based upon that. Beep. Here you see a picture of a graphite mine. Beep. Pencil factories almost always make their pencils in identical ways. The cedar lumber that the factory receives is cut into slats. Then each slat is given a hollow center for the lead. Finally, the slats are cut into individual rods. Assuming this process takes 2 hours and is done at room temperature, there are the following thermodynamic values. Beep. For this to happen, the wood must be transported from forest, and again assuming a distance of 100 miles and 20 miles per gallon, there will be the following thermodynamic values for the combustion of octane in the engine of the truck. Beep. This retroanalysis begins in the forest where machines are used to cut down trees. Assuming 30 gallons of octane are used and there is an internal combustion temperature of 353 Kelvin, the following thermodynamic values represent the Gibbs free energy and entropy of the universe involved in tree cutting.
Beep. Erasers have been on ends of pencils since the mid-1800s and are known at pencil factories as plugs. Most plugs are made of synthetic vulcanized styrene butadiene, which is what this retroanalysis is based on. Beep. At the end of the eraser making process, the 3-foot-long eraser ribbon is cut into smaller segments and attached to the end of the eraser. Assuming this process takes about a minute for one pencil and is done at room temperature, here are the following thermodynamic values. Since this process is rare, the thermodynamic values are based upon a similar process of slicing. Beep. The transport of the materials from the manufacturing plant to the pencil factory, assuming 20 miles per hour and a 100-mile trip, has the following thermodynamic data. Beep. In the manufacturing plant, the eraser material is extruded into a long strand and then cut into 3-foot sections. Assuming this process takes an hour and is done at 313 Kelvin, it has the following thermodynamic data. Beep. The rubber is made by polymerizing styrene butadiene, a process which is very similar to the copolymerization of styrene. The latter is a process of which data is easier to find, so the values are based off of this. Assuming these processes are identical and the polymerization is done with 40 kilograms of material, it has the following thermodynamic data. Beep. The last topic pertaining to the pencil we will retroanalyze is the paint on the pencil body. As most people know, the majority of pencils in the United States are painted yellow, and there's good reason for it. When pencils were first made, most graphite came from China. To tell consumers that their graphite was made in China, they painted pencils the color yellow, a symbol of royalty and respect. In addition, the smooth paint layer keeps the wooden pencil from splintering the user and makes it more comfortable to hold. Beep. The last step in the painting process is the mechanical energy involved in painting the finished pencil. Assuming this takes about 30 minutes to finalize, it has the following thermodynamic data. Beep. Before this happens, the yellow pigment, resins, solvents, and additives are mixed. Assuming this process takes 30 minutes, it has these thermodynamic values. Beep. If the following paint material are transported at 20 miles per hour and it is a 100-mile trip, the processes have the following thermodynamic information.
One of the main factors in determining the total entropy change of taking a chemistry test is the creation and transportation of the physical paper in which the test is printed on. In order to do so, I first analyzed the trees from which the paper was ultimately created from. Beep. Trees grow to great heights as a result of the photosynthesis reactions found in their leaves. This reaction is fueled with great help from the solar energy provided by the sun. Beep. Once the trees grew to a sufficient height, they were harvested by harvesting equipment, a process which takes approximately 12 hours. The cutting and mulching of trees uses approximately 30 gallons of gasoline, and the total change in entropy for this process is over 10,000 kilojoules per Kelvin. Beep. Once the trees were harvested, the product was transported from the harvesting site to a manufacturing mill, a process which consumes approximately 5 gallons of gasoline and has a total entropy change of over 1700 kilojoules per Kelvin. Beep. Once the harvested wood product had reached the paper mill, the manufacturing process could begin. The paper making process is time honored and consists mainly of mixing the pulp and slurry from the harvested wood, followed by a rolling process. The first known use of paper is thought to be from the year 105 CE in China. The mixing of the paper slurry and pulp is a process which consumes approximately 1,000 kilojoules per hour, assuming that the mill's operating temperature was 25 degrees Celsius. This was determined based on the similar process of mixing a large vat of paint materials, a value which was easily obtained. Beep. Following the manufacturing of the paper, the product was transported from the mill, which is located in China, to the port in Port Newark Elizabeth Marine Terminal. This is a process which utilizes about 1.6 million gallons of fuel, as this is a transport over a distance of about 20,000 kilometers. Based on the relatively poor fuel efficiency of large transport ships, this process has a total change in entropy of about 7 million kilojoules per Kelvin. Beep. Once the paper has been transported from China to the port in New Jersey, it must be